Okay, we're back. Hopefully you had a chance to try these two problems. Let's go through them and see how you did. Here are the answers to example 3. Okay, the first thing I did was I solved for A. I had side angle side. I solved for A, setting it up, and I got 21.3. And then the order that you solve for angle B and angle C really didn't make a difference. Both of them were acute, so you didn't have trouble with using law of sines either way. I got that angle B was 36 degrees and angle C was 44. Let's take a look at example 4. Example 4 was side, side, side. I could have found any angle first. I chose to find C first using law of cosines, and when I did that I got C as 107. The other two angles were acute, so it didn't matter which one I solved for using law of sines. 32 was A, 41 B. I could have solved for angle A first using law of cosines, or law of B first using law of cosines. What I would have wanted to do, however, is avoid using law of sines to solve for angle C. Because remember, law of sines cannot give us an obtuse angle when we're solving for an angle. So hopefully you did a good job on those. And our next thing we need to do is tackle some word problems. So let's give this a try. We've got a plane flying 350 miles from A to B at a bearing of 30 degrees east of north. And then the plane changes directions. It's now traveling 70 degrees east of north for 60 miles. So let's draw this. When I have compass bearing problems, I make a little x and y axis at my starting point. So this is point A, where we're starting. It says we're flying 350 miles at 30 degrees east of north. So from the north line, I'm going to go 30 degrees east of that. That's supposed to look straight. That's 30 degrees for 350 miles. That takes me to point B. And at B, I continue to fly east of north, but this time at a 70-degree angle. Your angles don't have to be perfect, but if they're way off, your triangle is going to look like it's going the wrong way. So 70 degrees is most of the way here to the 90. Let me switch colors. That takes us to point C. So I have 70 degrees east of north for 60 miles. And you can see our triangle now. Well, we're in the law of cosine section, so chances are we're going to use law of cosines. I have two sides. I want to find this side right here. I need an angle to do that. So I need to find out what this angle here is. So let's use what we know from geometry. If this angle's 70, the angle right below it is 20. We've got our 90-degree angle. And then we've got that other little section. Well, what would that be? Yeah, it would be 30 right here. We've got alternate interior angles. So since this angle's 30, this is 30. 20 plus 90 plus 30 gives us 140 degrees. So now we have enough to go ahead and find the distance from A to C using law of cosines. X squared equals 350 squared plus 60 squared minus 2 times 350 times 60 times the cosine of 140 degrees. So I'm going to calculate that, plug it all in. I have to remember to take the square root, and I get about 397.8 miles. So the distance from A to C is about 397.8 miles. But we're not finished. It said find the bearing and the distance. So the bearing is that angle with a direction. Well, to go from A to C, I know I'm still flying northeast, but it's a little bit more than 30. I've got to figure out this little angle in here, let me call it theta, add that to the 30, and that will give me the complete angle that's going east of north. I could use law of cosines, but law of sines seems a little bit easier for me, so I'm going to use law of sines. Sine of 140 over 397.8 equals the sine of theta over 60. When I multiply, I get 397.8 times the sine of theta equals 60 times the sine of 140. Divide both sides by 397.8, and then I do have to take the inverse sine. I'm finding the angle, and doing that gives me 6 degrees. So this complete angle from the north line to this AC line is 36 degrees east of north. So now I have both my distance and my bearing. Let's try another problem. Two airplanes leave an airport at the same time. One flies 35 degrees west to north at 160 miles per hour. The other flies 70 degrees west to south at 170 miles per hour. How far apart are they? This problem's a little bit different because we have two airplanes leaving from the same spot. So let's make this the spot that the airplanes are leaving from. The one is flying 35 degrees west of north from the north line, 35 degrees west. The other from the south line, 70 degrees west. You can see how we're going to get our triangle out of this. The first plane is traveling 160 miles per hour for 2 hours. So that would mean it's traveled 320 miles. And the second one, 170 miles per hour for 2 hours, 340 miles. And we're trying to find out the distance between the two planes after those 2 hours have passed. Once again, the biggest part of these problems is the setup and getting your angles correct. If you get your angles correct, everything else falls into place. So we need this angle right here. Let's see. This is 35. This would be the complement of 35. This angle is 70, so we've got the complement of 70, giving us a total of 75 degrees. Now I have side angle side. I can use law of cosines. X squared equals 320 squared plus 340 squared minus 2 times 320 times 340 times the cosine of 75 degrees. Put all that together, and I got 161,680.97, but then I have to make sure I take the square root. The planes are about 402 miles apart now after those 2 hours have passed. Be careful when you're plugging things in your calculator. Remember, this is all attached. So what we can't do is find this whole quantity and then multiply by the cosine of 75. Only the 2 times 320 times 340 is affected by the cosine of 75. So be careful with that. Okay, let's see if we can get one more word problem in. Ship A is 72 miles from a lighthouse on the shore. Its bearing from the lighthouse is 15 degrees east to north. Ship B is 81 miles from the same lighthouse. Its bearing is 52 degrees east of north. Find the number of miles between the two ships. Similar to the plane problem we just did. Here's our shore. Now both ships are northeast of the lighthouse. So let's put the lighthouse down here in the south portion. I know that's a really good lighthouse there. So the ships are going to be up here, and I'm not exactly sure where they are. Let's put them there. So the lighthouse to one ship and then the lighthouse to the other ship, and then ultimately we want to find this distance between the two. My picture might not end up being perfectly scaled when I'm done with this, but let's see what happens. I know ship A, well, the bearing for the one is 15 degrees. Let's just look at it this way. And the bearing to the other is 52 degrees east of north. So from the north line, 52 degrees. This one has to be ship A then. And this one's ship B. So once again, from the north line, one is 15 degrees to the east. The other one from the north line is 52 degrees east. A is 72 miles from the lighthouse. B is 81 miles from the lighthouse. And so we're trying to find this distance. Well, we've got the two sides. All we need is the angle. And this one might be the easiest one yet to find that angle. 52 minus 15, 37. Using law of cosines, I've got my side angle side. X squared equals 72 squared plus 81 squared minus 2 times 72 times 81 times the cosine of 37. I plug and chug, giving me 2,429.7, and then taking the square root of that. Don't forget that step, or else these two ships would be really far apart. They're 49.3 miles apart. There's one last thing I want to show you in the time we have left, and this, I think, is a review from what you talked about last year. It's an area formula called Heron's formula. He was the guy who came up with this. And this probably looks familiar. To find the area, first we need the semi-perimeter. And the semi-perimeter just means half the perimeter. It is different than an average. If it was an average, I'd divide by 3, but I'm just taking half. So we take the semi-perimeter times the semi-perimeter minus the one side times the semi-perimeter minus the other times the semi-perimeter minus the third, and then take the square root of that whole product. We could derive this, but I don't have time, so we're just going to use this. Here's an example. A is 23, B is 26, and C is 31. I'm going to find the area of that triangle. So first I find the semi-perimeter. 23 plus 26 plus 31 divided by 2. That ends up giving me 40. My semi-perimeter is 40. So now I can calculate the area. It's this big square root. The semi-perimeter times the semi-perimeter minus side A, the semi-perimeter minus side B, and the semi-perimeter minus side C. And when we multiply all those together and take the square root, we get 292.7.